we have a couple definitions. You use significant digits in your science classes. I think my rules may be slightly different than the ones Mrs. Delaporte uses. What we do, you start by you count the digits from left to right, beginning with the first non-zero digit. Okay. If there is not a decimal point, then we don't count any trailing zeros. So you want to kind of jot down something here if you need. When I say begin with the first non-zero digit, if I said like 0.013, you begin with the first non-zero digit. So you wouldn't start counting until you get to the 1. Then you count the 1 and the 3. If I said like 1,300, if there's no decimal, you don't count those zeros afterwards. Significant digits. So if I said 0.042, you first count, starting from left to right, the first non-zero digit. So how many significant digits is this? 2. 0.005.
1.
First non-zero digit. Okay, C. The first non-zero digit is my 2. So we have 3 digits that work. On D, first non-zero digit is a 6. If you have a decimal, then you count everything after that. So that's 4 significant digits. E, how many would it have?
2.
If there is a decimal, you count all the zeros. So we get 5. But on F, there is no decimal, which means you don't count the zeros, so we only have 1. Questions on how to count those? When we're talking about significant digits, your answer can't be any more accurate than your original numbers. In other words, if I'm taking a measurement and I round everything to the nearest inch, can I say that my answer is correct to the nearest half inch? No, that wouldn't make any sense. If I were calculating something and I rounded everything to a whole number, could I say that my answer is accurate to the nearest hundredth? No, because I rounded all my original numbers. So we're not going to do significant digits all the time. When it comes time for a test or a quiz, I'll have you do it on some problems and I'll specifically say use significant digits here. But today's homework assignment, everything we're going to do is significant digits. So in other words, we're going to look at the problem and how many significant digits everything in the problem has, and that's how we'll use, or how we'll give an answer. We're also going to make a few assumptions in this section. Anytime I say triangle ABC, if I don't tell you otherwise, angle C is going to be our right angle. We're going to be very accurate in our answers, so you cannot round in the middle. We're not going to round anything until the very end. So let's look at this example. So in triangle ABC, let's draw this picture. So I'm going to assume that C is the right angle. Even though I didn't state it, from now on we're just going to assume that. Angle A is 40 degrees. side C equals 12, where would side C be located?
Hypotenuse.
Where is side A?
Between C and B.
And side B? Okay. Technically, when you're looking at that 40 degrees, since it doesn't have a decimal, you might think that's just one significant digit. Generally, the rule is if it's rounded to the nearest whole degree, we're going to count that as two significant digits. Just kind of a thing with triangles, nearest degree is like 2. If I did the nearest minute, then we would add in additional ones. Essentially what I want you to do is keep the same significance digits for the angles and the same for the sides. So angle B is pretty easy to find here. What would I do? To get sides, yes. But if I want the angle, what do you know about all the angles in a triangle? They add up to 180. So this should be pretty easy to find. You just have to do 180 minus the angles you already have. So angle B is 50 degrees. So if I give you one angle, the second one's pretty simple. We know they always add up to 180. Okay, to find my sides. If I want side A, you can use either acute angle. So if I just wanted to look from here, from angle A, side A is opposite, 12 is hypotenuse. What trig function? Sine of 40 equals A over 12. Do we know the sine of 40? Is that one from our hand trick? No, so we will use a calculator here. But I don't want you rounding in the middle steps. So I don't want you to plug sine of 40 in and get an answer yet. What would I have to do to get A by itself? Okay, now I want you to plug this into your calculator. First of all, get out your calculator, make sure it's in degree mode. And then you need to type in 12 times the sine of 40. I think I got 7.71345. Is that what you guys got? But how many significant digits do I want for my sides? The one side I gave you, 12, had 2 significant digits. So I need to round this to 2 significant digits. So my A is going to be 7.7. To find B, we have some options. I recommend, whenever possible, to use numbers given in the problem. If I use this 7.7, we did round that quite a bit, and it will throw off our answer a little bit. If we did Pythagorean theorem with this, it is going to throw off our answer a little bit because we have so much rounding error. That's why it's really important for you to show me your work. You know, on a test, if you had rounded something using significant digits and used that number, and you get a slightly different answer, as long as your work can back it up, then I understand where it came from and I'm going to give you credit. But if you don't have any work and I don't know how you got your answer, then you would lose points. To avoid that issue, let's just stick with using this 12. So from here, B is adjacent, 12 is hypotenuse, so that would be cosine. So then multiply our 12 over. So you're going to type in 12 times the cosine of 40. you get 9.91925. Two significant digits, you round following rounding rules. So what would that answer?
9.2.
Are there any questions on this one? Okay. Let's do so we have triangle ABC, C being the right angle. Side A would be where?
Between C and D.
Across from angle A, which would be down here. Side B, so across from angle B. Find the remaining sides and angles. So I need side C, angle A, and angle B. Let's start with our side. How could I find that if I know two sides? Pythagorean theorem. A squared plus B squared equals C squared. So I'm just going to type this in. 2.73 squared plus 3.41 squared. To get rid of a square root, typically we would need plus and minus, but if we're talking about a triangle, we can't do a negative. If I'm answering with significant digits, how many do I need?
3.
So what would I answer?
2.77.
Make sure you round up when needed. Okay. The other information I need are angles A and B. That's the piece that's new. We've never found an angle before. Let's use a trig function. So from angle A, the information given, I gave you the opposite and the adjacent sides. What trig function involves opposite and adjacent? Tangent of A equals the opposite, 2.73, over the adjacent, 3.41. If I want to get that A by itself, what do we do? You don't divide by it. We had some in section 2.3 like this. How do I move the tangent? You do that tangent inverse, tangent to the negative 1. Okay, so second tan, 2.73 or 3.41. So we get this. We had 3 significant digits for the sides, so if I round this to 3 significant digits, that would be 38.7 degrees. I also want to talk about some of the homework problems say to give it in degrees and minutes. If I wanted degrees and minutes, remember, my degrees I already know. To get your minutes, you take the decimal times 60. So type in that decimal times 60. it gives us 40.8. I only need 3 significant digits. If I said 41 minutes, that would be 4, wouldn't it? The 38 is 2 and 41 would be 2. So we're going to have to round this to 38 degrees, 40 minutes, if I said to give me degrees and minutes. You can't give more significant digits than we had in the original. Okay. Now that I have angle A, how would I get angle B? You could just subtract. We know they add up to 180. Since this is a right angle, really A and B just add up to 90. So I could do 90 minus 38.7. Which gives us 51.3. If I wanted to do degrees and minutes, you would have to do like 90 degrees minus 38 degrees, 40 minutes. It's 89 degrees, 60 minutes. So we get 51 degrees, 20 minutes. Again, you wouldn't have to give me both the decimal and the degrees and minutes. I'm just going over both, so however the question asks for it, you could answer. Questions there? I want you guys to do one. Kind of along these lines. I'm not asking for everything though. I just want you to find angle B. So side C, that's our hypotenuse. Side A. When it's a capital letter, remember that's an angle, so I'm asking for angle B. What trig function would you use here? Cosine. Cosine of B is adjacent over hypotenuse. So to get our B, we change it to cosine inverse. And how many significant digits do I want? 4. So I get B equals, you have 59.1977. If you round that, you can't say 59.19 because the 7 would make you round up. So if you round up, you get 59.20 degrees. For the 4 significant digits, you would put the 0 there. Any questions there? One other thing I want to talk about in this section are angles of elevation and depression. An angle of elevation is from a horizontal up. In other words, you start with a horizontal line and you move up from that. That's your angle of elevation. An angle of depression is from the horizontal down. So elevation up, depression down. The key to this is both of them have to start at a horizontal line. So we will try a few examples of this. Here's our first one. The angle of depression from the top of a tree to a point on the ground 15.5 meters from the base of the tree is 60.4 degrees. Find the height of the tree. What do you think I should do for this? Draw a picture. If I'm just trying to look at it, that really doesn't make much sense. So let's draw a picture. We have an angle of depression, so that's from a horizontal down. We're talking about the top of a tree. So here's my beautiful tree. I need a horizontal at the top of the tree. From there going down, this angle is the 60.4 degrees. Okay, it's going from the top of the tree to a point on the ground, 15.5 meters from the base of the tree. So this distance from here to here okay. If I look at that then, do I have a triangle in this picture? Yeah, we could draw one. I just drop this down. This is a right angle. Did I give you an angle inside this triangle? No. So we have to find the angle on the inside. A couple ways of doing that. We know that these two should add up to 90. So you could do 90 minus the 60.4. Or you could do alternate interior angles. These two lines are parallel, so this angle down here should be 60.4 as well. However you want to think about that. So this one, if we subtracted from 90, we get 29.6 for that one. Or you could label the bottom angle as 60.4. You just need one of those angles in your triangle. I'm looking for the height of the tree, so I'm looking for this side right here. If I use this 60.4, x is opposite, 15.5 is adjacent. What trig function is that? Tangent. So I could say the tangent of 60.4 degrees equals my opposite side x over the adjacent 15.5. If I want to solve for x, multiply over the 15.5. How many significant digits? 3. So I'm going to type in 15.5 times the tangent of 60.4. Comes out to be 27.2849. So 3 significant digits be 27.3. Height was in meters. So that is the height of our tree. Any questions there? Let's do. Okay, let's do another one. No, this is not working. Hold on. The length of a shadow of a flagpole. So if I want to stop right here, I need to draw a flagpole. Okay, not supposed to be a trick question, but it always gets people. Where's the shadow go? On the ground, yeah. People always want to label that as the hypotenuse for some reason. So, your shadow's on the ground. Alright, the length of the shadow of a flagpole, 55.20. How many significant digits is that? 4. And the shadow is 27.65. So the sun would be up here. I want the angle of elevation of that. Angle of elevation goes from a horizontal up. So it's going from the ground up. We're talking about this angle right here. Okay, so from that angle, what would my trig function be? .20 is opposite, 27.62 is adjacent, or 65 is adjacent. So we would do tangent. So if I want to get my angle by itself to move my tangent, I have to change it to the inverse. So we'll type this in as second tangent. And that gives me 63.3934. We said we need 4 significant digits, so we'll say 63.39 degrees. You guys have any questions on these? Do you want more examples like anything? I have extras of everything we've done.
Quick question.
Yes.
So for the angles,
Mhm.
like to find the angles, we multiply the bottom over, and then to find like the sides, we do the inverse.
No, to find the angle, we do an inverse. And this one we were looking for the angle, so that's when you have to move the trig function, so you do the inverse. When you're finding a side, that's when we set up the ratio, we can just multiply.
Okay, I have that.
Yes.
Can you do the show the minute thing like how you did it?
Yes, just like how to convert.
Yeah.
Okay. So let's say I wanted to convert this to degrees in minutes. You would take the degree portion stays the same. To get your minute, you take your decimal and multiply it by 60. So you do 0.3934 times 60. And that gives you 23.604. So we went 4 significant digits to round to the nearest minute, so that would be 24 minutes. Any other questions? Then we have a little bit of time. Oh shoot, do I have time to? I have one last type of example. I don't know if I have time to do it. I may start tomorrow with that example. I'm going to go ahead and give you the homework. So know that I have one more example I'm going to do. This is all the homework for the section. So it will be due, today's Tuesday, so it's going to be due Thursday. Tomorrow I'll do one example and then you'll have the rest of the class period to work on this.